will serve roughly 100% wind power at the sort of fractions you saw in those graphs. It's not filling all the voids, it's not absorbing all the excess, but it's helping a lot. So it's just a crude model. We want to do that in more detail with load included. Next slide. Okay, so we've created this industrial consortium, the Mid-Atlantic Grid Interactive Cars Consortium. Next slide. Which has electric companies that bridge New Jersey and Delaware and further south. PJM Interconnect, AC Propulsion designs electric vehicles, Atlantic County Utility Authority, Converge. So there's New Jersey companies as well as others, Delaware and other companies in the area. Next slide. So just very quickly, just to give you a sense of how we make these electric vehicles, and they're being done on a sort of 2 per month basis, but we've got now the state has given an award for training workers, so they can be done at much higher volumes now. Start with a stock Toyota Scion XB. It's a boxy but light vehicle that has good space for batteries and such. Next slide. That's got a gasoline engine in it, of course. We've got to get rid of all that yucky stuff. Next slide. So we pull out all the engine. Next slide. We're just going to go through here. That's the drivetrain that came with the car, with carburation and pistons and all these, oily metal parts. Next slide. We're replacing that with an electric drivetrain. The yellow is the electric motor. That's actually a housing around it. The motor is about half that size, so it's much smaller than the gasoline motor and more powerful. Then you put that in. You put the power electronics unit on top. Next slide. And this is all hand done right now, so it's relatively expensive. Next slide. And then you're done. You've replaced a gasoline motor with an electric motor, batteries, and a big power electronics unit. Next slide. So the way these are configured, this is a bit of an exaggeration by the manufacturer. It's 120 to 150 mile range, 0 to 60 in 7 seconds, 95 miles per hour top speed. It's fully highway capable. It's actually more powerful than the gasoline version it replaces, and they're really fun to drive. They have very good pickup. When you let off on the gas, you get regenerative braking that's much more strong than what you would see on, say, a Prius, so you rarely even need to use the brakes. It can do 2 hours fast charge or 12 hours with the small plug like you'd see on the outlet, a typical home outlet. Next slide. And it's a bidirectional charger. This technology is built into the drive electronics that run the motor. It's actually almost no extra cost, a couple of $100 to have a very high power grid connection. Next slide. Okay, so several projects going using these type of vehicles. We have 6 funded in the Delaware area. State Fleet is buying in conjunction with the university, and the DOE is providing part of the funding. And those will be providing ancillary services. We're seeking funds for wind leveling tests, which we'd like to do with ACUA and also a Delaware coastal site. So it'd be nice to see how these actually work. I mean, we can model it, but we want to actually have the vehicles running. That's not funded yet. There's a nonprofit in the ISO New England territory that has lined up funding for 30 vehicles. So that would be about a 100 to 200 kilowatt contract for ancillary services. So they will be a paid ancillary services provider. They'll have a contract. They'll have to meet their contract obligations. And that's a very good bit of discipline to actually be in the market. We're getting a signal right now, but they'll actually be they'll be a generator. And they'll have to meet the requirements of a generator. Of course, it's 30 cars, so sometimes there's 20 cars online and sometimes there's 25. So there's going to be management of that fleet of vehicles. California, we've got a single vehicle right now. We're trying to get set up to process the Cal ISO signal. So if these are successful, we'll have 3 of the country's independent system operators that we're dispatching vehicles to meet their signal, and also hopefully a couple of wind leveling tests. Those are not funded yet. So if we got one more slide. So summary, lots of large-scale CO2 power in our region. We're going to be energy exporters. I'm going to vouch for that in 15 to 20 years. New Jersey and Delaware are going to be exporting energy. Right now, we're doing individual vehicle dispatch. We've shown a simple model of wind fill-in. I got 4 computer scientists. I got to hire another full-time programmer to get all the software up and fully operational. We're doing market research right now so we can see how much people are willing to pay for electric vehicles. Again, they're going to be more expensive initially in these small production runs. And then how do they want the contracts to do? So we're going to do a large sample with got an economist and a market research person working on that, and we'll be dispatching this small fleet that we've got. And we're looking for at a larger level of funding a full PJM megawatt contract. That's 200 to 300 cars, about $12 million to do that. So. We'll see if we locate some entity that wants to work at that level. But that's what we're doing. So I think that's the last slide. Yeah. And we do have a website, www.carbonfree.udel.edu. Thank you.